Okay, so
Okay.
before we start the class, let me say hello to our student first.
Sure.
Good morning everyone, selamat pagi semuanya, adik-adik.
Morning, Bu Vidya.
How are you? This is our first class in the Ramadan, ya, in the Ramadan months. Hari pertama ya, kita kelas ya setelah kita kemarin libur awal puasa. Rasanya kuliah jam 7.30. Teman-teman sudah semangat ya.
Yes, maybe they have something change for our meeting here, because tomorrow we have around 5 days for holiday to start the Ramadan month, like that.
Okay, so this is our first day in Ramadan month because of in this several days ago we have a day off, 5 days off. So this is our first meeting after the day off. So I hope the students very excited, yeah, to join with us again, to study again. Okay, so in this meeting, in the previous meeting, we already learned about cross section and also time series data with Kate, right? We talked a lot about GDP data, and for today's meetings, we will continue the subject about data analysis, isn't it, Kate?
Yeah. Okay. Thank you very much.
Okay.
Thank you very much. Yeah, last time. Yeah. Thank you very much. Last time we discussed time series and its some main features and some important things about it. We also compare time series and cross-section. We also discussed where we could take data, what data set I could use. And today I would like to focus on how you could explain the results that you get finally in the estimations. I will start with this one because sometimes it's quite complicated for a researcher. And then we will finally discuss how I could make forecasts based on GDP growth of Indonesia. So this is a plan, and like previous time, we are not fixed with plan, so it's okay. Any question, any comments, it will help. So if you have some comments, if you have some questions, free to ask, free to put it in the chat box, because it helps. Because I don't know how information you are listening to is enough or not for you. So anyway, feedback is great. I think so. So feel free here.
Okay.
And also today I have another equipment, and because I would like to share screen, not just for basic things, but also with some explanation, for example, in formulas, some explanation in dynamics, and sometimes in PowerPoint it's impossible. And that's why here I will use, wait a minute, I will show you, and I would like to test it, because for Chinese students it's not always work great. So I will try it here. Wait a minute here. Yeah, it's okay. So yeah, it's okay here. So I will use it after some explanation, after maybe some comments. When I use like Blackboard, I will use it. So today our organization of lecture will be a little bit different, because last time I understood that I really need Blackboard to draw something, to explain something, or to put formulas there. So today it will be me here with PowerPoint and Blackboard in case we need some formula explanation, some definition, and some other things we need to understand today's material. So, okay, let's start then. Last slide, as I remember, wait a minute, I share my screen here. As I remember, last slide was somewhere here, and we finished it somewhere here and said, okay, what does it mean? I explained what does it mean when we're talking about gross domestic product by expenditure and constant price. And we also put here, what does it mean? And now we start here. Don't be afraid again. That's why I have my blackboard, don't be afraid. And here, I want you to demonstrate one thing. When you have time series and you would like to analyze what factors do influence on your dependent variable. So let's me put it here. I will try to demonstrate it right here, what I'm talking about. So for example, you have dependent variable. You have dependent variable. It is dependent one. Dependent variable. And you would like to understand how, for example, X1 and X2, for example, influence on it. You could take, for example, GDP here and consumption here and investment here, for example, and investment here. And you would like to understand how your consumption and your investment in your country influence on your GDP. So you put equation here and you, okay, my GDP here, somehow consumption influence on it, somehow consumption influence on it, plus investment influence on it, plus error terms or something else influence on it, but I didn't take it into account in this equation. So you put it right here. This is final equation you would like to understand. Maybe it's not, maybe it's better to put it right here because it's not like a level of it, just a variable. So consumption here and investment here, and you would like to understand how it influences on GDP. Here is one problem. If you use GDP, so let's have a look something like this. If you use, for example, 1st January 23, 2nd January 23, 3rd January 23, here is time, here is GDP, and here is investment. I don't know, maybe 7-1. For example, it's just example. It's just example. And investment, for example, here, it's just example. So it's okay because you have GDP here and investment level here. And when you get your estimations, for investment, for example, you will get this one. You will get alpha 1. Alpha 1 is your estimations that you will get in startup, for example. This is your estimations. And it's not problem to explain it. You explain it how you could explain alpha 1. For example, you get alpha 1, 0, 0, 3. How could you explain it? You explained it quite easily. You said, okay, if investment grow on 1%, it means that GDP grow on 0.03%. So it's easy. When you get here time series for GDP, and when you have here time series for investment, it's easy for you to explain what results did you have. But sometimes you need natural logarithm. Sometimes you need to use logarithm. Log. Sometimes you need to use log or differences. Sometimes you need use differences or natural logarithm. Why do you need to use it? For example, you take GDP. You take time series for GDP And what does it mean? We have already understand that GDP is growing for any country. So if here is time and here is GDP, GDP will be growing from day to day. So it is growing, growing, and growing. So what does it mean? It means that if you use it, you will find trend inside of it. There is a trend inside of it, growing trend inside, and it gives you problem in estimations because you don't need trend at all. That's why you need to eliminate trend from it. How could you do it? You could use natural logarithm and you could use differences. So you need to take away this trend. And you use natural logarithm, for example, for variables, and it looks like under logarithm something like this, for example. Or differences, it looks another way. So you don't have trend anymore. And it's okay for you to make estimations, for example. So sometimes you could have this situation. Sometimes, first case, as we discussed, if you put it right here and you have alpha, you explain alpha quite easier. You explain it if xt is growing on 1%, y will growing on alpha 1%. So it's easy to understand. But what if you use natural logarithm from both sides? What if you use natural logarithm from both sides? Sometimes, quite often, honestly, you use natural logarithm quite often. I'm sorry, quite often you use it. Quite often you use logarithm as they help you to eliminate trends at all. Then, if I get my alpha 1, for example, 003 again, what does it mean? And how I could explain it for reader, for references, and for others, because here I have natural logarithm. Good news here is that it is the same explanation, because natural logarithm is quite good function. And it is good function, why? Because I know that, for example, if I take derivatives for X here, for investment, for example, I will use it right here because it is just a feature of derivative here. And if I multiply here for 100, I mean for percent, I will get the same story. You could see it here, it is alpha 1. So what does it mean? If you use natural logarithm here, and you get alpha 003, it means the same as in previous. So it is the same if x10 is growing. If your investment is growing on 1%, your GDP will grow on alpha 1%. So the same story like in previous one. But there is the third and the fourth case, and sometimes you also could find it and it could give you some problems. For example, sometimes you need natural logarithm, for example, for GDP, and investment don't need it. So sometimes the third, you could use your natural logarithm for GDP here, and you understand that your investment don't need it. So for investment, you didn't use it. Natural logarithm was only here, and there is no it here. And then if you get these estimations, what does it mean? How to explain it here? How to explain? In previous time, we said, okay, I could explain it with percent. So if X, for example, investment is growing on 1%, okay, my GDP will grow on alpha 1%. But here, because GDP is under natural logarithm and investment is not. And again, I use derivatives here, and I could find it that, okay, here, if I take it, again, here is the feature of natural logarithm, and I could put, for example, and I know that it is alpha 1, sorry. I know that it is alpha 1 from this side, and I could multiply it on 100 both sides here and find, okay, what does it mean? It means that if x is growing on 1 in absolute sense, for example, on $1, for example, in 1 euro, for example, on 1 yuan, in $1, it means that y will growing on alpha 1%. So difference here. If your GDP is under natural logarithm and your investment is in absolute sense, it means that when you explain your estimations, you remember that when I get my coefficient here, when I get alpha 1 here, it doesn't mean that it will be increase in your GDP in the same sense as investment. It means that here you will have just if your investment grows on $1, then your GDP will grow on alpha 1 and 100%. So this is a difference here. And the last but not the least, the fourth version here, the first option here, when, for example, a researcher decides to put it here. So, for example, we are talking, okay, I have GDP, and GDP is an absolute sense, for example, and here I have natural logarithm for investment. So natural logarithm inside from another point. I don't spare your time, and I don't take time from you to understand how it could be here, but still I will ask you on the slide, there will be some explanation. If you are interested in it, you could have a look on it. But still here we explain it in such a way. If X is growing on 1%, it means that Y is growing, GDP will growing on alpha 1 and 100%. And the same story for formula and the same story for derivatives. And I will show you it just in a moment, how I explain it and how I prove it. You will have it on your slide here. I will show it for you. And I also remind you that it is very important. And before you implement all methods, just think about your formula, think about your equation, think about the idea before you implement all necessary methods you would like. So here is better. I demonstrate you with alpha, it doesn't matter. So just it's another letter, but it's okay. The same story here. And also explanation, how I could explain these estimations. If I get results, now how I could explain this dependence for those who will read me. So it's very important. And finally, after all this basic preparation and basic assumption, I would like to discuss with you some methods of focusing on GDP growth. I used GDP, as I have already mentioned, for Indonesia. It was calculated based on expenditures, and there is a growth rate of GDP in expenditures. And here we will just discuss it and have a look at it. So I will start from, let's make it here. I will start from how you could export data. I remind you that unfortunately here at home, my university is closed right now because it starts works only at 9. And unfortunately, here I don't have starter on my computer, and that's why the decision was to demonstrate just some photos from it. And you see here, I failed to use data from Fred, but maybe it will help you. You see, remember last time I demonstrated you that there are some useful data. For example, Fred use Fred's data. Fred data allows us to find GDP for Indonesia, GDP for Russia, for United States, many statistics, many time series. So you could use this command for you. First of all, you could use this one. Sorry, I will just, first of all, for sure, you need installed, you need to put this function on your computer. And after that, you will just use it. Unfortunately, I failed because it's impossible to update data from Russia right now. If I failed with it, I need to wait a little bit, maybe soon it will be okay. But still, you need somehow, you could try because it helps you to import data from Fred statistics side, from Fred website to here. Another point that, for example, if you import data, if you put it inside here, and it is quarterly, for example, Stata won't understand you because Stata need 1, 2, 3, 4, 5, 6, 7, 8, 9, so something like this. Or sometimes you could generate something difficult for Stata. Sometimes it understands more difficult version, but you don't need, you not always need it, because you just would like to make regression and to test some statistics to understand whether there is dependence or not. So I don't like to make things difficult if I could make it easier. So I never use difficult time series here, not time series, time variable, I'm sorry, time variable. I just make it like this. I generate new variable. I named it trend, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is like time changes variable. So I put it right here, and now my variables, they do have all these things. They do have all these variables inside it. So it helps. And after it, I also asked my starter, this thing to test whether these variables are time series. And starter told me, yes, it is. And it has 130 period of time series and only one variable. Yeah, for sure, we have one variable. It is GDP here. So time variable GDP for all these variables. So next we will just understand, okay, I imported, I just put it in the starter. I just put my data inside it. And what else? You need to make this one if you would like, for example, to present graphs, to present some analysis, to make some analysis, to make some estimations, to make some something else. So anyway, if you would like to use data, not cross-section, but time series, it is obligatory, it is necessary for you to put this comment here. It is like a rule for you, and you need to make it here. Okay, so after that, I used this function. So I asked starter to put graph, to draw for me the picture, and it is just comment test line. It is fixed one. So I had variable 1 here. You see, just after that, I put it variable 1 for you. Do not be confused about GDP, for example. So here will be your name of the variable. So you put it here, for example, GDP, or you put here, investment. So any variable that you need to put on your graph, you will put it here. And again, be sure that before everything of that, you did tset comment, this one, because without it, if you use time series, it's impossible to make any analysis because you need tset anyway. And as is a graph here, I remember we saw it already here, and I understand it is GDP growth rate. So it is growth rate, and there is no trend. I understand it. And before any estimations, I need to be sure that this time series is stationary. So that it changed somewhere in the mid. So you have something like this. For me, it's okay. I don't see trend. Anyway, I will ask Stata to help me to check it. But honestly, right here, I don't see the trend. And it gives me hope that I will just start to make the forecast of this data without any doubt. And but still, I would like to check it, and I will start from descriptive statistics. So if you would like to find descriptive statistic, you just put summarize and the name of your variable. Here, growth rate is the name of variable, so be careful. It's not a comment, it's name of my variable. So summarize and your variable. And you will find the number of observation, mean, standard deviation, minimum and maximum value here. And okay, you could see here there is a mean value, but I would like also to find median one. So mean and median differ. And sometimes you could use not this one, but you could use, for example, this one, univar. And again, your name of your variable here. And here you will find median value. And it is a little bit bigger than your mean variable. What does it mean? It means that your disturbance of your variable is a little bit right center. So your mean and your variable, they differ. It's okay for data if it's stationary, but still you need to think about it. And you need to understand that in estimations, for example, you need to take it into account anyway. So I think you know about histograms, and that any disturbance, any time series has its histogram. Histograms show you the frequency of your, I don't know, your variable, your meanings of your variable. So if you have, it means that here there are the biggest number of all variables here, and in Stata you have some things that may help you. And again, you here is the median. So here is the median. You see here 1.226. It is not a mean, it is a median. What does it mean? Maybe to make it easier, I will draw it again on my blackboard to remind you what does it mean when I have different disturbance here, and I have variables. So I have variable here. It is GDP for Indonesia. For Indonesia. And for sure, it have, we saw it have some just graphs like here, some, for example. And so this is time variable, and here is GDP. And what else? I would like to analyze this data, first of all, for its disturbance, for its characteristics, how it could be divided. How often, for example, I have the question, how often GDP of Indonesia is in interval from 0 to 1%. So I have a question: how often your country grows with a growth rate that in the interval from 0 to 1%? How often it happens? Or maybe your country during this period of time grows with growth rate 10% quite often. Or the most years that I take into account, your country grows with 5%. So I have this question. I would like to understand, okay, I observe this variable, but the question is how often I could observe these growth rates. So how often it happens. How could I do it? You use histogram. Histogram will show you this one. It will show you here with the correct frequency, so how often it happens. And here will be values of your growth rate. And in our case, it looks like this one. What does it mean? So here is the most number of GDP growth is here. And for sure, you could see that here is like straight line. So it is like symmetric from this to this, and it is mean. In our case, mean is equal to 1.7. What does it mean? It means that the number of observations here, is equal to number of observations here. So number of observation from both sides are equal. So number of observation here and number of observation here, they are the same. So it means that I have mean 1.27. So during my period of time, that I used, I have 130 observation. So 65 years or quarters, I had quarters, I'm sorry, 65 quarters, and 65 quarters are here. So they are divided into two parts, and these two parts are the same. Also, what does it mean? But if I have, I'm sorry, it's not mean, I'm sorry, it's median. Mean for us, it's a little bit here. Mean doesn't mean that there is the same number of observation from both sides. So median give you the equal number here and here, the same number of observation. Mean gives you mean value of it. So in terms of histograms, it doesn't help. It helps for you to answer the question, for example, and during this year, my mean, is it higher or not? Is it bigger or not? So you just could understand it somehow here, just to explain how it could help you to explain this variable during this period of time. But still, histograms will help you to understand whether your variable is approximately okay with disturbance, because you remember there are basic assumptions for you when you make model. And you need to use normal disturbance, you need to have some others, and sometimes it is a great problem. Sometimes we don't have it, and sometimes we need to test it. And here I see, okay, GDP for Indonesia, predominantly, you see there is a 0. So predominantly during period of time that I used, predominantly all years it was positive. I could return back and see it here. Predominantly, only few years when GDP were negative, only few of them. More period of time when I observed GDP was higher than 0. So here is more variables here, more the number of GDP here is higher. So it was okay. Okay, so here histogram could help you to analyze data, and sometimes in article, in science journals, you could be asked to put your histogram inside the text, your kernel density, for example, estimations. They differ, but it's okay if you put only this one in your publication and discuss, okay, you see here is a mean and there is a medium, so it could help. And stationarity. It is the biggest problem for time series. What does it mean, stationarity? And again, I used my blackboard here. And first of all, I will try to explain you in words something like this. For example, you have GDP. Not GDP growth like we do. We have GDP growth for Indonesia, and it saves us because growth, it means that you have not absolute value, but relative value. And relative value, they are easier to analyze for stationarity and for these purposes. Okay, and if you have trend inside your data, if you have it, you need to take it away. Let's again, I will demonstrate you on blackboard what does it mean here, because on the slide it is like final version and this is starter explanation that you have in starter data and in starter help version, for example. So if I'm talking about stationarity, what does it mean, stationarity? It means that you have, in terms of mathematics sense, it means that you have unit one, so one unit root. Sometimes one unit root. Sometimes it is named one unit root, and you could use it for non-stationarity, for example. So again, let's think about GDP for Indonesia that we have. And for example, I have such dependence for this, and it is such dependence. And if we sure for GDP, if we observe for GDP, for example, this is GDP growth, not growth, GDP, and here is absolute value, you could observe that there is just growth all the way. There is growth of GDP. What does it mean? It means that each next meanings of GDP, for example, here, dependent from GDP from the previous period of time. So if you have growing trend, it means that if I'm growing, every next variable will be higher and higher and higher. So there is dependence between my next meaning, my next value, and my previous one. So my next value will be higher if I have growing trend, and my growing will be not just less and less from each time because I have just declining trend. So here is a problem, and here is it is not a good thing. Why it is not a good thing? Why trend is a problem? I will just why trend is a problem? Why trend is a problem? For example, we have country 1, country R. And country 1 is getting richer and richer and richer and richer. So income in this country is growing and growing. What does it mean? It means, remember that we have already discussed, people could buy better houses for themselves. So it means that households could buy better houses because they are getting richer and richer with swimming pools. Remember that case that we discussed last time with swimming pools, because your country is getting richer and richer, your income is higher and higher, and you could buy yourself great home with swimming pool, with something like this, so with richer and richer. From another side, for example, you consume more electricity. So here, the number of swimming pool, if I'm growing in here, so here is the number of swimming pool, and here is T, it will growing. And here is electricity consumption, and it will also grow just because we're getting richer and richer. And if you, for example, would understand the dependence between these two variables, so if you will have the purpose to understand whether the number of swimming pool in their country influence on consumption of electricity, you will find this dependence. So if you take the influence of number of swimming pool on your electricity consumption, you will find for sure the dependence between them. And it doesn't mean that one variable will influence on another one. No, not in this case. It means that these both variables have growing trend inside. So when you don't eliminate trend from time series, it means that when you will make the model, when you will make the estimations, you will include this trend in this process. And if, for example, dependent variable and independent variable have the same trend, for example, increasing one because of increase of wealth in country, it means that they will both demonstrate you the dependence between them. But it doesn't mean they have it. It means that they have trend. And that's why trend is a problem. And that's why when we're talking about stationarity, we asked data not to have trend. We ask data not to have trends at all. We ask data not to have trends, because if they do, if they have trend, it means that I will have this situation. And it means that each next one variable, it's not variable, each next meanings of your variable will be dependent from the previous one. So previous one will dependent from its previous one, and etc. So you need to somehow to take it away. So our basic hypothesis is that beta 1 is equal to 1. So we assume that if it happens, for example, it happens like this one. If it happens, if here we have 1, for example, it means that we don't have stationarity and we do have trends. So this is bad things. It means that we have non-stationarity. And it means that we need somehow to solve the problem. Stata used another way a little bit. Stata just put this variable to this side and ask for beta, this B1 is equal to 0. So it differs, but still I tried to explain you the basic idea. And a basic idea was that if you have trend inside your data, if it is growing trend or if it is declining trend, and if your next meaning depends on previous one, you need to do something. What could you do here? Let's have a look on it. And what I could do here, wait a minute. I will just, okay. I will just demonstrate here again how I could solve it. Wait a minute. So Stata use it.
Kate, sorry. Kate, sorry.
Sorry. It's okay. It's okay. Could you hear me? I'm sorry. It is a problem when I use two equipments because sound is only one.
That's
and
fine.
It's okay. Okay, it's okay now. Okay, I will repeat my last idea. So we have a variable, we have GDP, we have GDP growth, and GDP growth for us, it is dependent variable and independent one. And we assume, okay, there is a growing trend. For Indonesia, we saw it, so it is a fast growing country. And I would like to eliminate this trend at all. I don't like it inside of my data because it doesn't help me to explain some issues inside of it. So here I put minus previous GDP here and minus previous GDP here. Mathematics science allows me to do it, so I put it right here and I put it right here. Here is like change of GDP, and here is the previous thing. And now the same story. My test for stationarity in Stata, it changed a little bit, but the idea is the same. And now I'm talking not about just B1, but B1 minus 1 is equal to 0. Because if B1 is equal to 1, this one is equal to 0. So it is easier for me because I know a lot of tests that allows me to use it. So, okay, here is options for Stata. Stata said, okay, sometimes there is not only problem from your previous meanings. So GDP could have not only problem because of previous meaning. If I had high GDP level last year, I will have it higher rate today. It's obvious. But also sometimes some variable dependence on time series, for example, time period. If you are looking for data that doesn't depend on it, so in economics and macroeconomics, it's difficult to find it. So Stata offers not only B1 here, but also change for time variable. And it calls drift and trend. And in Stata, there are different options. So I will show you briefly here. And here is for here is for drift. Here is for without drift, sorry, for drift and with trend. So, but anyway, it doesn't matter what do you put after your comma here. So you see, you put Dicky Fuller because it is his test. Was his idea to test stationarity based on coefficient, based on difference in coefficient in changes. So it was his idea, and we implemented it here. But after you finish it, you see here is different words here. So if you would like to analyze trend data or drift data or something like this, you will put it in such a way. So random work with trend, random work with drift, and random work without drift. You just put different words here. But story is the same. I know that I saw the program when Inayat sent it to me, and I saw that you discussed basic assumptions of some regression models. And you know that one of the basic assumptions for example, student statistics, it is built on comparison of calculated data, calculated statistics, and its critical value. And the idea is that good news is when your test statistics is higher than your critical value. And here I could observe it, I could see it, and for sure here I could just implement it. And I see, okay, GDP growth for Indonesia is okay. It is okay in terms of random work without drift. It's okay in case of random work with drift, and it's okay for random work with strand. So in all cases here, we found that the time series was stationarity. Okay, so, okay. I also would like to ask about, we discussed some organizational issue in the beginning of this lecture, but I didn't ask you about, maybe we don't need breaks today, because if we need to find earlier, if I understood, 9:15, so maybe without break, or it's too difficult without break. What do you think, colleagues? I need your advice. Do we need break today or not? What do you think? Or maybe just without breaks and end up just finish at 9:15.
I think we can have a break for 10 minutes. Maybe okay. After that, before we have a break, I would like to, what is this? Underline what you already told about to us, right? Okay. So you already, you mentioned about us, about how important we do eliminate the trends. And you already explained why we need to eliminate the trends. When we try to use VAR, yeah, we need our data to be stationary. That's an important one. But maybe later you can mention to us, to the students, because of some of the students here are never have the VAR materials before. Yeah, most of the students who come to the class today, it's currently learning about regression. But maybe you can mention to us what actually VAR
means.
Yes, and what kind of data that we can estimate in VAR. Maybe that maybe
okay. You
can highlight that for us before after we have break in 10 minutes.
Okay. Okay.
Yeah.
Okay. Thank you very much.
Yes.
I'll just put myself some marks not to forget. Does it mean? Okay. Thank you very much. Thank you for your feedback.
And also
10 minutes.
One more point about already. Yeah, I understand actually what you explained about to us before. Yeah. Can you explain about us about? About, sorry for this.
It's okay.
About we have several steps when we estimate our data with VAR. The first one is we should test the stationary, right? And then after that, if it's not stationary, what should we do? And then if already stationary, what should we do? Maybe what is that? The step that we have to do when we want to estimate using VAR. Okay. I think that's.
I put it on my blackboard, just like points to start with, for sure. Yes. Thank you very much.
I think that's
maybe else some remarks, some comments, some maybe feedbacks.
Yeah, I will try to communicate with students after this. If they're
Thank you.
I can deliver it to you later.
Thank you very much.
Okay.
10 minutes, 10 minutes,
Yes,
5
10
minutes.
minutes. So we will back
10 minutes.
on 8:35, right?
Okay, okay.
Okay, thank you very much, Kate.
Thank you very much. Thank you.
Okay, guys, we will have a break for 10 minutes. Please stay with us and we will come back on 8:35. If there's any question for you, you can write it down in the chat columns. You can write it in Bahasa Indonesia. Ya, kalau misalnya teman-teman kesulitan buat tanya, boleh ditulis Bahasa Indonesia, nanti saya coba bantu untuk translate in English. Okay, see you in 10 minutes. Welcome back again, Kate.
Yeah, yeah. And we could start then. And just again, I will try to share this screen just to answer your question and your not only question, your comments, okay, and to focus on these things. Here is my comments that I did for myself. So let's start for VAR. What does it mean? Remember in the beginning of our meetings, I will explain you how to explain some, for example, estimations. And I said, for example, you have time series, GDP and investment. And let's call, for example, GDP for this variable and investment for this one. We have observation for time period. So, for example, here is 1st January, 2nd. For example, for sure, unfortunately, we don't have for any day. Let's have a look here, for example, years. Years. Etc. So, and here we have some values. So just figure some numbers. Here some numbers. So just meanings. And we do understand that GDP depends on investment. But we also understand, remember that the idea often is in the center of your research. And if you remember, the topic of our last meeting will be VAR in the whole sense. So I would like to make some steps go into the final VAR estimations. But still in the beginning, the idea is that I would like to find the dependence between two variables, between two economic variables. And I would like to understand how they influence on each other. So first idea is to find how investment could influence on GDP, how it could just define GDP. But also I understand that GDP today, so your level of development also depends on your past time. So it really depends, what did you do last time, yesterday, day before yesterday. So if you tried to invest a lot of money in your economy, it gives you results in the future. And if you have today great country, if you have today great welfare, it means that in past period of time, you did something great. So we understand that on GDP, also investment in different period of time also influence. So GDP really depends on level of investment, not only during this period of time, but also previous periods of time, and it helps to create great GDP today. So from one point of view, I understand that investments in previous years influence on today's GDP. From another point, I also think that GDP depends on its levels. If your country is huge, if your country is quite have a high welfare, if it is just well-developed country and highly developed country, each next period of time, you will feel this effect of the previous great years. So your GDP, if I put it on the picture, your GDP, if you're analyzing it like dependent variable, depends from one side from investment. For example, from investment, let's call it X, from this period of time and from previous ones. So GDP depends on how good your investment last years, you invest last years, how many time and many money you spend for the economy. And from another way, it depends on its previous level. Because if you are too huge to fail, too big to fail, it means that your GDP for sure depends on your previous levels. So this idea could be put into the equation. And that's the reason why I put equation at the end, because sometimes for students, it is quite difficult to put the equation when you have it. So here is equation for GDP in our case. And for example, I could explain it here. So here is GDP, and here is some legs of your GDP. Like here it is equal to 3, for example. In my example, it is equal to 3. And I could explain it in economic sense that if I'm, for an example, United States, I couldn't fall drastically because my economy is strong and I feel good, I feel myself quite good. So it means that if you are well developed, if you have a high welfare, it means that next time you will also feel yourself quite good. And so GDP for today depends on your previous levels. Also, if you are interested in investment role in GDP, you also put here investments. And also, economics is quite complicated things. And for sure, this is plus error. And you see, okay, investment in this year really matters, but I know that investment needs time to give results, to give them final results. And what does it mean? It means that, okay, you say, okay, I do need to include in my equation some lags in investment, and you did it. So here is a VAR. You see, I would like to give you some steps because to estimate this one is a little bit difficult. That's why I give some steps. And I start VAR estimations. I started to make it from this side. So for today, it is only for air period for one. So I have, okay, GDP growth for GDP. For GDP in Indonesia in this period of time is equal and depends from GDP growth of Indonesia in the previous period of time, plus error. So I would like, first of all, to discuss what happens if you have only this part. And then second step will be, here I would like to discuss stationarity, estimations, how I could explain estimations, what should I do if I don't have stationarity, what should I do if I have any problems. So to discuss some problems here in this part. And then in our third theme, I think that I will change topics because we will have only 2 meetings except this one. And maybe I will change topics because I would like to start for whole VAR, because maybe I won't have time for some topics here. So I will include this one. So then we will take this part. We will also include in our model some other variables and say, okay, and what problems occur if I include not only my own values of the previous period of time, but also other variables in my equation. So what happens if I do it? What happens if I include not only growth rate, but also variables and its lag? So here is a plan to give you VAR model step by step. So first part, when I include only my own levels of the previous period of time, and second one, when I just include others. Talking about stationarity, because it was a great comment about stationarity. Remember, in stationarity, we said that there is a problem when I'm dependent from my previous level. And here I said we should take it into account. The difference is that when you had it like problem, it has just, remember when I take, okay, I have stationarity, we are talking about stationarity right now. We said that here, for example, it is equal to 1. It is a problem. When it is equal to 1, we will discuss also at the end of our meetings, in the 4th meetings, that there is a special test for VAR estimations. And this test means that I will check whether this coefficient is less than 1. So the problem is when this coefficient is not equal to 0, because GDP depends on its previous level. The problem is when it is equal to 1. So when it is equal to 1, it is a problem. There is no stationarity. So we have trend. And here we come to second comment. What should I do? I check stationarity. I check it. And if you check stationarity, and you could find and you could make 2 conclusions. First conclusion is no, and second is yes. If no, everything is okay, like in GDP growth for Indonesia, we found that there is no trend, there is no drift, there is no random walk, so everything is okay. If there is stationarity, what should I do? First option, to take differences. But the most, quite often, especially if your variable is higher than 0, if your variables are higher than 0, for example, if it is GDP, if it is investment, if it is consumption, so your variable is higher than 0, then you use natural logarithm. You use not GDP, you use natural logarithm of GDP. You use not investment, but you use logarithm of investment. During our 4th meetings, we will use it, we will discuss it, and we will just remember, I try step by step to introduce you for VAR estimation. And we start from easy things. We start from just model when I include only my own previous value. So we start from R1 model for GDP. And I start also, we found, okay, our time series are stationarity. So there is stationarity in them. So, there is no, they are stationarity, I'm correct. There is no problem with non-stationarity. So I'm sorry, here is non-stationarity for sure. So if there is non-stationarity, if you say no, it's okay. If you found that they are not stationarity, it is a problem, and you comes to natural logarithm, and you make different things with your time series here. So to start with, for our today's meetings, I use just very simple example, and we didn't have such problem inside it, and we didn't face with it. So it was okay. It was here. It was great for us. It was normal. In one meeting, or maybe next time, we'll discuss what should I do if I have a problem here. And one of the decisions is to use natural logarithm. And now we remember our discussion today. If, for example, you use natural logarithm, be careful with explanation. Be careful with explanations. Because, for example, your dependent variable will be okay, but your independent variable will be with problem, and you could use natural logarithm for it. And here, remember, you have some features of explaining this coefficient, these estimations. So if you solve problem of non-stationarity with natural logarithm, remember of our discussion how I could explain estimations if I use natural logarithm for one or some, not all of my variables. That's the reason why researchers often use natural logarithm for all variables. So it's not important is there stationarity or non-stationarity. They use natural logarithm because they don't want to have problems with explanation of these estimations. So if you don't want to have problems with it, you just use natural logarithm of all your variables. If you test natural logarithm, and again, there is a problem of non-stationarity. So you use natural logarithm for GDP, for investment. You test stationarity and again have problem. What could I do? You use differences of natural logarithm. Honestly, when I make my research, usually I use differences of natural logarithm. Differences of natural logarithm. So you use it, differences of logarithm for yourself, so without any doubt here. Okay, so this is how we are talking about stationarity. I remind you that we start different steps. So our dream is to understand VAR model. And we just make some steps to here. And now we are here, the first step, and we start only when I include only my own legs without other variables. So here I include only my legs without previous levels. This is the first step here. Then we will have second step. We will add also not only my own, we will use not only my own my own legs, but we also use just my independent level legs. Sorry here. So this will be our next step. And this is our third or fourth meeting. So today we are here. Today we would like to understand how I could explain my GDP growth today due to my knowledge about my last meaning of this variable, how I could explain my GDP growth today, independence of my previous GDP growth. So this is my idea. This is my thing that I would like to know. So now, while you are thinking about questions, maybe comments, I would like to come back here in the slide, and again, I remind you that there is no problem for stationarity. In one meeting, we will discuss on examples, what should I do if I do have problem. So for now, I'm happy because this growth rate, you see, it's not an absolute value, it is a relative value. And that's why I have no problems. So again, here I would like to, usually, if we are talking about AR1, what does it mean, AR1? I'm sorry, I will just show you. It is like here. Wait a minute, I will just show you. It is like here. Wait a minute. Again, I have here. Wait a minute. So I said, okay, I just have AR1 estimations, and okay, I said, you see, here is a final VAR model. So when your GDP depends on your previous levels and depends on your other variables, for example, here. And today we discuss this part. Today we take without V, just AR, it is called AR, auto-regression model. One means that I have only one leg. So it is the beginning, it is our first step. Soon we will evaluate all this model. But right now, I would like you to show the instrument that sometimes researchers used only one part. So we said, okay, GDP growth is equal to alpha 1 GDP previous level plus error. Here is plus error. So here the idea is, okay, R1 auto-regression, because just I have only from auto, so only from myself, dependence from only myself. And here is 1 means that N is equal to 1. It is a very famous model. It is highly used, especially in stock markets. Best news about stock markets, when you include stock markets somewhere, it gives you a lot of problems. If you include stock market indexes in regression, in VAR regression, in VKM regression, a lot of problems, because stock market is highly volatility things, and nobody loves it because it really create difficulties for your equation. That's why, for example, when you analyze stock market, or if you analyze, for example, Apple company and its stocks, you use it one by one. So you leave stock markets alone. So you don't put inside different regression, different regressors, different determinants and others. You just leave stock markets alone. And here you could use, for example, stock market. And this model quite often used for forecasting. So you could use it and you could make forecast based on it. And I would like to demonstrate you based on GDP, how you could do it. You saw the steps. First step was to test stationarity. We said it's okay. And then we get, okay, we need estimations. Here, I will just give you also forecast, how I could make forecast based on this quite easy model, because only one dependent variable as independent variable, it's lag. So just quite easy one to demonstrate you that var is quite useful, and you could just don't use all var in the whole, you could use only parts of it. So, and again, I will just demonstrate you results for estimations here. And what did I did? I just give you this presentation. You do have this presentation. And here are some issues here. So I made estimations, and I keep these estimations, wait a minute. I keep these estimations inside of my computer memory. And I also exclude my last 3 estimations. So I would like to make the forecast and to compare it with existence estimations to understand whether it's a good idea to use var model for GDP. So here I store all estimates and name it Kate. You could name it as you would like, as it's okay for you. And for sure you could make it after reg function. I don't demonstrate you here because I would like you to think about it a little bit, and next time we will take the whole model of var estimations. Now I would like to emphasize that even part of var model could be useful, but still we will make our focus on the whole model. But still here it is just, it helps. And I make forecast, and when I make it, I just use and compare and take my estimations. I ask Stata to remember them, and I create forecast here. And I ask Stata to draw it. Here is a command when you use, for example, two-way. Line is a fiction name for graphs. var2 is just for variable that you need to draw. So for example, for us, it is GDP of Indonesia. And you see here is a special variable here. We have a f and variable inside. And I would like to trend means my variable for time series. And I asked to put a special name for axis X, and this means that I have this one. So there is actual data and there is focus data, and you see that we failed. So this is actual data and this is focus data, and it didn't work. I again explain what did I did on the table, because for you not to be confused a little bit. So I have a small number of estimations. I have GDP here for a moment. So here is alpha 1 GDP and error. And I have estimations here, estimations. And okay, I said, okay, it's okay. But I would like to, I have 130 observations. So here is a time period or number, and here is GDP growth. And I have something like this, I have 130 of them. I divide my whole sample on 128 numbers, make the forecast based on them, So I make forecast for this number. I make a forecast for this number, and then I compare it with data that I really had. I did it because I would like to demonstrate you that for GDP, you need, and for economic sense, you need to include whole VAR model, not only AR model, so it's not enough. We saw it, we understood it, we understand how we could estimate it. We understand that, okay, you could find it reg var 1 L var 1 and get results. And in your sense, we get results here. We could discuss it, but I didn't do it because I would like to do it in whole var model, because it's not var, it's like part. Remember, I said it's only the part of whole var model. And still we saw for GDP, it's impossible to use this forecast at all, because just GDP, first of all, the problem is that the number of observation. We have not enough, quite small number of observation. So it is small number. It was used only for your example, but in real practice, it's small number. Second one, it is GDP. It's not market value. If you use, for example, market data, maybe it will be better. But still here we faced this problem because it's not enough. And our model is not enough. We need VAR model. And for sure here, you see this is real data. We see the decline in GDP. And when I did forecast only based on R1 model, we saw problem, we saw the growth of it. It is really a problem. So what about conclusion here? And we could go to our questions. Sometimes it's not enough to take only, I'm sorry here, to take only, wait a minute, R model. Not only it's not enough, you need VAR one. I will just demonstrate your slide again. You need to use VAR models, not only AR one. Especially, I think that the problem here is that we had circumstances of COVID-19. And you see, even if you failed with some forecast, don't be upset. You need to explain what was the problem, because it is also the result of your research. Now, I think that GDP was quite unstable because of post-COVID-19 situation. And this model, it is quite easy. And my goal here was to demonstrate you some main features before VAR. So I would like before VAR model to demonstrate your histograms, to demonstrate your Dickey-Fuller test for non-stationarity, to tell you about natural logarithm implementation and explanation and implementation and explanation of estimations you have and estimations you have if you implement it, if you use natural logarithm. I think that I will change a little bit the program, and next time we don't discuss this one. Maybe we will let it for last thing. Next time we will start to estimate the whole VAR model and see on impulse response function. So today we discussed a little bit what does it mean, VAR models, that there are some parts of it when you could include only a level of variable for t-1 period, t-2 period. And then we will discuss about idea that I could implement and make it just something like this. So, dear colleagues, am I right that we need to finish at 9:15? So in 6 minutes, yeah, right?
Okay, yeah, we should finish at 9:15.
Yeah. So just maybe I'm sorry that I took time, but I would like to finish before next time, before huge war models. So sorry. Maybe any questions you could email me. So it's okay.
Okay. Thank you very much, Kate. That's quite interesting explanation about FAR. That because of our student usually in this point, some of the students only learn about the recreation itself. But this is it could be an alternative, if the student want to forecast about some variables. For example, the GDP, and you mentioned before, is for stock prices, right? It also usually use the FAR for forecasting. Okay, before we end up this session, maybe I would like to ask the students, is there any questions for Kate? We still have 5 minutes left if there is someone who want to ask the question over here. Ada yang mau tanya enggak ke Kate tentang apa yang dijelaskan tentang FAR ini tadi? Okay, maybe later, because of this is a new subject for them. Maybe they need time to process.
It's okay. It's okay. You know, some students emailed me last time after our meetings, and it's okay. I also apologize. Sometimes I don't have opportunity to answer day to day. So because sometimes I have classes for Russian students or for Chinese, but still I answer. So it's okay. You could email me and think about it and email me, or for example, don't be afraid to email me, okay? It's quite complicated maybe to add some formulas on the slide because I had my own experience, and for Chinese students, formula and equation on the slide makes them scared. That's why I use Blackboard just to write with them together. Just you see, it's not so scared. I could do it, and you could do it as well. So I'm open for all suggestions, and so.
Yeah, that's right. Sometimes students already scared watching our slides, before we even explain about it.
Yeah. So it's okay, and I understand it totally because students are the same, and we are the same, despite our nation. So it's okay, and so I'm free to answer email or something like this. So feel free.
Okay, very kind of you, Kate. Okay, so later, if you have a question for Kate, you can email her. This is the email in the column chat. You can save it first, Maybe later when you need it, you can communicate with Kate, and also you can ask about your question about anything about econometrics, especially in this subject FAR. Okay. I think that's all, okay, because we still have 2 meetings left, and then we can continue to discuss about FAR in the next meeting with Miss Lustina and also with me also. I think we should end up this session for today, and I hope to see you in the next weeks.
Yeah, sure. Thank you very much.
Okay, thank you very much. Okay.
Thank you very much. Thank you. Bye.
Bye. Okay.
Bye.
So this is our last session today. Thank you very much for the student who come and join with us today. Thank you for Kate, and also thank you for Lustina, who stay with us from the beginning. We have a presents form over here in the chat column. Please fill it for the students, Silakan diisi kolom presensinya. Okay, thank you very much, everyone.
Okay, thank you.
Bye.
Thank you. See you next week.
Terima kasih semuanya. Silakan diisi sebelum live ya. Terima kasih Bu Lustina. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Jangan lupa isi presensinya ya, teman-teman.
Baik, Bu.